All right, hi everyone. So today I wanted to show you how you're going to do that match that graph simulation on physics classroom. So first and foremost, the link that I have on Canvas will send you here. You're going to put in your name and then say start. You're going to do all of these levels right here, but I'm just going to go straight to the wizard level because I want to show you how I want you to draw the acceleration graphs. So once you're done with all this, these little trophy things will be lit up. And what I mean by lit up, they're just going to be colored in, like it's going to be yellow with a red star, I think. So once all three of these are colored in, once you finish them and you have your name right here, take a screenshot of this part right here, and then you'll post your copy paste that screenshot into like a Google Doc or a Word document so that you can upload it onto Canvas. So another thing that I wanted you to do, which I have in the directions, is in the wizard level, you'll see that you have a velocity graph and a position graph. And the whole reason this is called match that graph is you want to match these together that have the same motion. And I'll show you what I mean by that in a second. But I also want you guys to draw the acceleration graph for that motion as well. Okay. So, and just do that on a separate sheet of paper. And and just take a picture of it with your phone. That's usually what I have you guys do. So take a picture. And then when I do stuff like that, I usually will like email myself the picture and then just copy paste it into a document or something like that. So match that graph. You are given a graph, and then you want to toggle through these graphs by just clicking, and it'll change the graph when you click on it. So you toggle through this to match the graphs together like that, basically. Okay. So sometimes you're given a velocity graph, sometimes you're given a position graph here, and then you want to match them. So here, since I'm given the velocity graph, we want to remember that the velocity is going to be the slope of a position versus time graph. Okay, so I talked about that in the Intro to Motion lecture that you should have watched already. So because the velocity here says that it's a constant positive velocity, so see, it's constant because it's not changing, and it's positive because that's a positive sign. So since we have a constant positive velocity here, we should have a constant positive slope on the position versus time graph when we match it. So I'm just going to toggle through. Obviously, this is a negative slope, so that's not our answer. This is not a constant slope. Do you see how at the beginning here we have a slope of 0 and then we have a negative slope at the end? So this does not match either. This doesn't match because, again, the slope is not constant. It's changing. It starts with a steep slope and then goes down to a slope of 0. And then here, this is the one that's going to match because it's a constant slope and it's a positive slope. All right. And then so you're going to then hit check answer and it'll show that it's correct. Now, the other thing I wanted you to do is on the wizard level and only the wizard level, you don't have to do this for every single level. I want you to draw a acceleration graph as well. So when you do that, it'll look something like this. So you want to draw the little graph lines just like it has on velocity. And just do this on a separate sheet of paper, like I said. And then here you want to look at your velocity versus time graph because we know that the slope of a velocity versus time graph is going to be acceleration because slope, again, is rise over run. Rise here is change in velocity, run is time, change in velocity over time is acceleration. So here we can see that the slope of this graph right here is just 0. So for this specific situation, you're just going to draw a slope of 0. So I just will go down here. That will be my slope of 0. You can do it in another color like I did. And that is my answer for the acceleration graph for this situation. Let's do another one just because that's kind of it's kind of easy. So check answer. You'll see that it says that away, like, yay, we got it right. And so we're going to continue. So here's another situation where they give you the velocity versus time graph first, and then you want to match the position versus time graph. Sometimes they'll give you position versus time over here, and then you have to match it with velocity. So it can be either way. So here we can see velocity is positive to begin with, and then it goes down to 0. So here velocity is changing. So remember, on the position versus time graph, the slope is velocity. So we want a slope here to start at a really high positive number and then go down to a slope of 0. So here you can see that the slope is constant, so that's not going to be it. Here we start out at a slope of 0, and then we go to a high positive slope. So that is also not a match because the velocity would have to start down here and then go up to match this one. And then here we can see that we start out at a high positive slope. You just draw like a tangent line like I'm doing with the cursor, and then we go down to a slope of 0. So this is our match. Okay, and then another thing we want to do again is draw the acceleration versus time graph. Remember, acceleration versus time, the acceleration is going to be the slope of the velocity versus time graph. So here we can see that we have a negative slope, so it's going to be a negative acceleration. So all you want to do is just draw, and it's constant because the slope of this velocity versus time graph is also constant. It's not changing. So all we want to do is draw a straight line because it's a negative acceleration. Okay, so that's all I want you to do for your match that graph. You will, again, copy paste the screenshot with all 3 of those trophies colored in or lit up. And then you will also have all of your 12 acceleration versus time graphs for these different numbers right here. And I would number them like they're numbered right there. Okay, good luck, and email me if you have any questions.